All right, good afternoon, everyone. Oh, you guys are much better than my undergrad class. That's fantastic. Thank you. Hello, and my name's Rob Golden. I will be have the pleasure to introduce this year's BENDELOW lecturer. I'm the acting department head in the Department of Plant Science at the moment, and so this gig comes with the job. And I will introduce Dr. Ian Godwin shortly. I would like to first speak a little bit about Dr. BENDELOW. I really did take my glasses off because my eyesight is not what it used to be. And very briefly, Dr. BENDELOW, to whom we owe this lecture, is or was born in Sheffield, England. He lived in Yorkshire until he joined the Royal Air Force in 1940. Came to Canada to take his flight training, and then he served as an air crew navigator in Europe and Africa. Following that, he was discharged from the Army or the Royal Air Force in 1946, and he immigrated to Canada in 1948. He then took a BSc, MSc, and PhD in the Department of Plant Science, I believe. I wouldn't recommend that these days, but that was probably okay then. And worked as a serial chemist at the Agriculture Research Center from 1951 until 1985. And then upon his passing, unfortunately in 1991, he left this gift behind, and we have the pleasure to use that to invite and bring in distinguished lecturers every year or so. So to introduce our lecturer this year, his name is Professor or Dr. Ian Godwin. He has over 30 years experience in plant biotechnology research, first undertaking sugar beet genetic engineering research at Birmingham University in the UK. In the 1980s, so I think those were the early days, he joined the University of Queensland in 1990, holding an academic position in plant molecular genetics. In 2019, he joined the Queensland Alliance for Agriculture and Food Innovation as director of the Centre of Crop Science. And there he oversees over 150 crop science researchers and PhD students. He leads research in the use of biotechnology tools for crop improvement with emphasis on sustainable production of grain crops. Major focus is on the improvement of crops for food, feed, and bioindustrial end uses. He's pioneered the use of GM and gene-edited techniques in sorghum. And his research projects include international collaborations with a focus on food security and plant genetic resource conservation, with collaborators in Germany, Denmark, the United States, China, Ethiopia, and Pacific Island countries. He's led research projects attracting over $60 million Australian in funding, and is the current Australian lead of the International Research Training Group in accelerating crop genetic gains. He's very passionate about public communications, which we'll find out today, and science. He's spoken at many public events on genetics, GM plants and food, animal cloning, and the future of agriculture in a changing climate. In 2003, he was awarded an ABC Science Media Fellow, and he appeared on ABC and BBC Radio on numerous occasions. 2021, he was awarded the Australian Medal for Agriculture, and his popular science book, Good Enough to Eat: Next Generation GM Crops, was published by the Royal Society of Chemistry in 2019. And with that, please join me in welcoming Dr. Ian Godwin.
Thank you. Thank you very much. I've got this lapel mic, and does that mean you can hear me? Not yet. Okay. Yep. Okay, so this one, I have to use this. Is that going to give me feedback or something? Okay, I'm getting ready for my ears to go boom. For those of you who want to find out about my research, you'll have to wait until my talk on Thursday. I'm mostly going to talk about some of the stuff I've had public outreach with, including, as mentioned, my book, which happened to be called Good Enough to Eat, with a question mark. And it's a pleasure to be here in Canada, and thank you very much for inviting me to this prestigious lecture. And I have been to Canada before, except that it was Quebec City, and everyone I tell that I've been to Canada before, they say, oh, if you went to Quebec City, you haven't been to Canada. So it's good to be in proper Canada. Okay. I want to talk about food, because we all have our own personal relationship with food. Now, on this picture, you'll see things that might be some of your major food groups, some things that might not be in your major food groups, some things that you've probably never eaten. And I, for one, have definitely never eaten starfish, to my knowledge, but who knows? And food is one of those things that I know from some of the research and outreach I've done becomes very emotive for people. But I also have a personal experience that I want to share with you. This fine young fellow dressed in the military uniform with the ostrich feathers on his head is my maternal grandfather, Vince. And when my grandmother died, Vince came to live with us. I was about 10. And I didn't know him that well, but one morning I said, "Do you want some jam, grandfather?" as I called him. And he said, "What sort of jam is it?" And I said, "It's plum." He said, as soon as I got out of the trenches, I said, "I'm never going to eat bloody plum jam again." Now, it turns out there was a reason for that. So in the trenches in the First World War, the officers got strawberry jam and the enlisted men got a thing called plum and apple jam, which tasted disgusting apparently, mostly because it was about 95% turnip. And that put my grandfather off the whole concept of plum jam. And I think we've all had experiences like that with particular foods. I mean, for me, it was as a high school student with tequila, but I shouldn't talk about that. But you also know that food's going to kill you. There's lots of evidence. Every day we hear about the foods that are going to kill us. And you know, in my mind, I hear these things and I think, I've got to stop eating bacon, especially with vegetarian food, because it just improves the flavour of the vegetarian food so much to me. But what you can see here is this is a research program, a long-term study in a large number of countries. And what they were mostly showing was, apart from diets high in salt, the thing that people were dying from was not eating enough of certain things, like not getting enough whole grains, not having enough vegetables, not having enough fruits, those fiber types of things. These were the things that were killing people. So we have to think about that all the time when we're thinking about food sustainability. It's not just giving people nutrition. You can't just provide everyone in the world with a daily diet of fish and chips. There has to be more to it. We have to have nutritional sustainability as well. I'm going to tell you a little bit about some more of my values. Both of these things to me are definitely not foods. I don't know if you've seen the thing on the right, and it's known as a chayote, or in Australia we call it a choco. Yuck. Again, I can go back to a story of my other grandfather, who said during the Second World War, when Australia ran out of pears, they cooked these things up in sugar and sold them as tinned pears. I think they were slightly better than the turnips, but I've never tasted them. The other thing, I'm put off celery because I spent one summer as an undergraduate student harvesting celery. Now, you may not know this about celery, but it has these things in it, furanocoumarins. And when they get on your skin and are exposed to ultraviolet light, as in when you're picking celery, it makes you hypersensitive to ultraviolet light. And you get blisters on your hands, on your arms, if you're stupid enough to wipe your face, on your face. But they're actually widespread in a number of different foods. This one actually comes from lime juice. There's actually a terminology that apparently it's a common thing when people go on holidays to places like Mexico and they sit beside the pool all day and drink margaritas. You get margarita mouth because the lime juice has actually made you susceptible to sunburn on your mouth. So there's a few little food things for you, but I really want to go into plant improvement. And most people know this story. The original progenitor of maize was a thing called teosinte, and domestication and selection has led us to a plant that looks absolutely nothing like what it looked like. And maize has gone through a large number of fairly revolutionary things and it's led a lot of those. So hybrids were first introduced in the 1930s. And then by the time the 40s came along, the first urea-based fertilizers came around from the Haber-Bosch process. And these things started to make productivity go better. And then once motorized agriculture basically replaced the horse, as they said in America, you didn't have to space your corn rows based on the size of a horse's ass. you could actually reduce the size of the rows. And that led to some big increases in crop productivity. But what I will get you to notice though is as that increased, it also meant that you were more susceptible to big variations in food production when you got years when it rained too much or it didn't rain at all, etc. Now, I was an undergraduate student in the 1980s. That sort of probably, it's fairly self-evident. But I was really excited because I decided to do a PhD in a thing called biotechnology, which when I was at school didn't seem to have been invented. The first transgenic plants were made using agrobacterium, or nature's genetic engineer. And this was actually a kind of magic. And I've used a bit of an illustration here. You can actually start to treat genes like Lego. So you can take a piece of a gene from an eggplant and another piece of a gene from an apple and another piece of a gene from a potato. And in fact, we're not even limited to plants. You can take a gene from a rhinoceros if you want to and put it in a plant. You can take a gene from a bacterium and put it in a human if you want to. And if there's a good reason to do that, and if it's legal, which of course is another thing that we have to think about. But that led to some really, really big increases in agricultural productivity in many parts of the world. So by 2018, almost 200 million hectares of GM crops were being grown around the world. Now this map's just to give you a bit of an idea of the scale of that. So if you can imagine the amount of GM maize grown around the world, it would cover the entire country of Spain. Everything, the mountains, the lakes. There'd be no Madrid, it'd just be maize. Soybean would cover the whole of France and the whole of the UK. Canola would cover the whole of the Czech Republic, and cotton would cover the whole of Italy, even including Sicily and Sardinia. So big areas of the world became covered in GM crops. In Australia, our first GM crop was BT cotton. And for two reasons. Partly, it wasn't regarded as a food crop, so it was easy to get through the systems that needed to go through. But secondly, because cotton had become unsustainable in Australia. So by the time you got to the mid-90s in Australia, the main pest, Heliothis or Helicoverpa, most farmers were pretty much spraying their crop every week to keep that pest at bay. Now you might be wondering why I've got a picture of a snake there. I love to tell these personal experiences, particularly the ones that show how stupid I am. I did another summer when I was an undergraduate student working with a cotton breeder up in central Queensland, a place called Billawheeler. And he invited me over he was actually from Texas, and he invited me over to his house one Sunday for lunch. And then suddenly a brown snake came across his yard heading straight towards us. And because I'm stupid, well, he ran inside and I thought, oh my God. I picked up a hoe and I thought, oh, I'll be able to kill this, chop its head off, no problem, because I'd done it before on snakes that are slower moving. If you've never heard of an eastern brown snake, the medical advice about the eastern brown snake is either get to the hospital for the antivenin within 15 minutes or just lie down under a tree and write a letter to your loved ones. And funnily enough, the snake had a few goes at me, and I don't know why or how it missed me, but basically I was pogo sticking across that lawn on a hoe. And then the guy from inside came outside with his shotgun, and I thought, shit, he's going to shoot me, and he didn't, because, he's Texan. And then the snake disappeared under a shed. And then we all sat down again, very calmly, to have lunch. And then the phone rang. And then Mrs. Brengman went inside and she came back outside. Quick, everyone, take in the washing. We've got to go. I said, what's this about? I thought, the snake's gone. It's told all its relatives. It's bringing the whole family back. We're all dead. But no, it was the neighbour, the next door neighbour, who was a cotton farmer, had phoned up and said, hey, I just want to let you know I'm about to spray the cotton, so you better bring your washing in. And that's what was happening all over Australia and many other parts of the world. People were talking to one another to say, hey, I'm about to spray, get inside, close the doors, get your washing in. And in rural communities, it was sort of an unknown, it was an unwritten rule that you don't spray when the kids are going to school and you don't spray when the kids are coming home from school. But schools got out at 3 o'clock, by 3:30 everyone's home, and out came the sprayers. That was quite normal. So in cotton producing towns, it was a big deal. And BT cotton was accepted in those towns very quickly because it had social license, and that's because endosulfan and beer gardens don't mix. It had a big effect on pubs. You had to close the beer garden. No one wanted to drink their beer outside in these beautiful parts of the world. It also, because of the use of endosulfan, there was so much endosulfan in all the rivers and waterways, there were no fish left. So anyone who wanted to go fishing on the weekend had to drive a long way away from the cotton areas. And most of the cotton is also Roundup ready as well, and that led to a huge reduction in pesticide use. So this was really, really a fantastic use of the technology, and it became very, very easily accepted to nearly all of the population, except perhaps the population who knew nothing about cotton production. It then got released in India, and this is where it really made some big changes. And you can see there that once BT got released, there was a slight increase in the amount of BT cotton grown, but the production went up a lot. It was a massive success in India, basically catapulting India to be the #1 cotton producing country in the world. Some of you may have heard of the BT cowpea in Nigeria against Maruca pod borer resistance. This was done with the assistance of TJ Higgins from CSIRO in Canberra. It basically helped farmers in Nigeria to sustainably produce cowpea, which is their main source of vegetable protein. And so much so that many of the neighbouring countries like Cote d'Ivoire and Ghana, wanted to get in on the action, and farmers are now really hitting their government up and saying, hey, we need to allow this GM production because this is good. So I can stop now because it's all good news, right? All of us plant scientists, including Hamid, if you can spot him there, lived happily ever after. And then, as many of you know, that wasn't actually the case. We all got hit over the head. We were environmental vandals. We were terrible people. So all of us sort of plant scientists who were involved in this work and thought we were doing great things for life, the universe, and everything, found out that actually no, we were criminals who were in the hands of criminal multinational companies, and it hurt. It really hurt a lot. We had lovely people like Vandana Shiva, who, depending on which day she was talking, said 400,000 Indian farmers have committed suicide since the failure of BT cotton. I mean, you've seen the graphs, the failures rather non-existent. But then on other occasions, she changes the numbers, just depends on who she's talking to, and etc. And our king, our wonderful king, I think when I first did this slide, he was only a prince. Something happened and he's now a king. He said that people will be driven off their land into unsustainable, unmanageable, degraded and dysfunctional conurbations of unmentionable awfulness. And I can just imagine him saying that. I don't know what it means, but it sounds really posh, doesn't it? Here's some reality. This is actually a graph made by a guy called Ian Godwin from Manchester University about male and female farmer suicides in cotton growing states. And even when BT cotton was released, before that there had been a slight increase in males committing suicide. The female numbers were going down anyway, and you can see that after there was no increase, it was actually a decrease. But you can say what you like, whenever you like, depending on who you're talking to, if you don't need data. And what the world, some people in the world didn't understand is BT is so that you don't have to use insecticide. It's a replacement for insecticide, and we like to think of it as a very sustainable replacement. And we've got the ability to have fungal disease resistance as well, so you don't need to apply as much fungicide. But we're not quite doing that yet because it's not acceptable. And some of you have heard, and I heard these a lot because people were telling me, just family friends were telling me, oh, well, you know, if you work on GM crops, you know, they're all toxic, obviously. And they'd talk about all the farmers in India who are committing suicide. And then they'd tell me that BT corn killed monarch butterflies. I don't think that many of them in Australia had actually seen a monarch butterfly, but they knew that it had killed them. And then farmers were being forced to grow GM crops. And then all GM crops require toxic chemicals. So if you buy anything that's GM, it's going to kill you. But the worst one of all was GM is not organic. So we've gone through all those. And I just want to talk a little bit about this not organic. Hands up if you've eaten organic food today. Have you knowingly eaten organic food today? I definitely have. Yeah, there's a few of you who have. In the dictionary, organic means relating to or derived from living matter. So all food is actually organic. It's real. Food is organic, except for salt. But as we know, that's the most toxic food, so we don't eat that, right? Certified organic is what people are talking about when they're talking about organic. And certified organic is different. And every country has its own system of saying what the rules are about organic. And some of them are a little bit more different than you would think of, because different countries have different rules about different forms of organic. Now, I have to say here that organic to me is a really good production system. And for certain crops, particularly some fruits, etc., it's actually very, very sustainable. It does reduce chemical use. It does make the land better, etc. I want to give you a couple of examples of some things though. So certified organic rules are quite clear. So in Europe, if you're an organic grower, you can use copper as a fungicide on your organic potatoes to control Phytophthora. In 2001, because there hadn't been a limit, the EU started to say, actually, we're going to limit that to 8 kilograms per hectare per year. The reason why they were doing that is because in some parts of the world that were growing potatoes, there was so much copper use, the ground was not only discoloured, it was toxic on the top level. So it was actually a very good herbicide because there was so much copper actually in the soil in some parts. And then they dropped it to 6 kilograms a year in 2006. In the UK, the organic rulings are made by the UK Soil Association. It says you're limited to 6 kilograms a year, but only if you tell us. So it's optional. If you choose not to tell us, you can use more. And we know that in really wet years, you'll have to use more. So just don't tell us. It's okay. And in Germany and Switzerland, they dropped it to 3 to 4 kilograms. And in Scandinavia and the Netherlands, they finally decided no copper is allowed in organic or conventional farming. You're just not allowed to use it at all. So if you go to a supermarket in Denmark to buy organic potatoes, they come from Germany. That's how you solve that problem. You buy it from someone who allows you to use copper that you're not allowed to use. And then for grapes, well, it's a totally different story. You can use up to 38 kilograms per hectare per year. And so if you go into an organic vineyard, you'll find there's not many weeds growing. So the organic rules are quite clear-ish, if I can put it that way. So it sounds like I'm making fun of organic. I don't want to sound like that, but I do want to make fun about organic marketing. It's this whole 100% chemical-free stuff that gets to me, because nothing's chemical-free except a vacuum. So, and I say this for someone who, as a youth, spent a lot of time surfing. And I went into a surf shop a number of years ago, and they had on sale chemical-free zinc cream as a sunscreen. And my inner scientist really wanted to say to the guy behind the counter, "What?" But I just thought, no, walk out. So I did. It's one of the few times I've walked away from an argument like that. You've heard of biodynamic agriculture? It's organic taken to cult level. This is not a biodynamic ice cream, it's preparation 500. So it's a cow horn, you fill it with manure, you bury it in the soil in autumn, and then you dig it up in spring, you grind it, add it in water, and you spread it over the field. What you can say is, if you do the maths, you're spreading about 40 grams of nitrogen per hectare across the field. So it's closing in on homeopathy, if I can say that. But there's even better ones. There's all these preparations which actually start to sound a lot like Levi's jeans. I've listed a couple of my favourites. There's the stinging nettle, which helps the soil develop an intelligence to accommodate the particular plants which are growing in it. That's pretty cool. That's powerful stuff in that stinging nettle. And then my absolute favourite is the yarrow flowers, which you have to place in a stag's bladder. Don't use a female deer's. No female deer's, no. You have to put it in a stag's bladder. You hung it in the sun in summer, and then you bury it in rich soil during the next winter, and you're a biodynamic farmer. And people pay for this. But that's fine, I guess. Remember, organic agriculture is chemical-free. They don't use chemicals. They only use allowable inputs. And here's a list of allowable inputs. Of course, copper being one of those. You can use salt. You can use theobromine, which is the stuff in chocolate that will kill your dog if you give your dog chocolate, apparently. Glyphosate, which is in Roundup, is not an allowable input. And many people have spent a lot of time trying to demonstrate how toxic and dangerous glyphosate is. I've never seen any evidence to actually demonstrate that it actually is. But one thing we do know is that it's more than 10 times less toxic than copper sulfate. So we have GM versions of disease-resistant grapes and potatoes, and we're not allowed to use them, and organic agriculture continues to spray with chemical-free copper. And overall, most of these production systems have about 50 to 70% of the productivity of conventional, and that's not even including conventional when you add the GM product. I'll finish with my favourite, which isn't my favourite at all. It's organic cotton. I try as best as I can not to buy organic cotton, and I'll explain why. It's not economically viable in Australia, so no one produces it in Australia. Australian cotton growers, they're all BT, some of them are also Roundup ready, they produce about 10 bales of cotton per hectare. They use 7.3 megalitres of water, and per hectare, this is enough cotton for over 15,000 t-shirts. It still means that they're using over 480 litres of water to make a shirt, and that's not including the water that is post-farm gate. So it uses a lot of water to make a t-shirt. Australian farmers also pay for their water, and they pay for the electricity to pump the water because it's pretty much all irrigated. Now, India produces most of the world's organic cotton. Organic cotton growers produce about 2.5 bales per hectare, so their productivity is about a quarter of what the GM cotton production is in Australia. So and that's okay if they've got environmental outputs that make up for that. But they use 12.4 megalitres of water to do that. And I'll give you a good reason as to why they use so much water. So per hectare, this is enough cotton for just under 4,000 t-shirts. So you've got about a quarter of the number of t-shirts per hectare. And they've used over 3,000 litres of water to make one t-shirt. And in general, in most parts of India, the water is subsidised, as in it's mostly free, and there's usually local areas that pay for the electricity to pump the water. So they're not paying for the water and they're not paying for the electricity, so there is no incentive to actually increase your efficiency of water use, which is a problem. I think it's a major problem. So you have to ask yourself, which production system out of those two is the most sustainable? What's the best for the environment? And I'll put this in a pictorial form. These are what in Australia I would call a 44-gallon drum. Maybe you call them a 55-gallon drum, I'm not sure, because you have a different gallon. It's smaller gallon. I understand that the size of the Canadian football is different to the size of the... So I'm just saying, obviously your gallon's smaller, but your drums are bigger, something like that. But so you need 16 of these to produce one t-shirt on a farm in India. And India's annual water use on cotton, remember they're the biggest producer in the world, actually is enough water for every person in India to have 85 litres of water per day for a year. Now, of course, the irrigation water is not potable water, But that puts it into a context. This is a lot of water just going into cotton, and a lot of it is because the biggest production areas are in Gujarat, and Gujarat without cotton production and irrigation would basically be a desert. So there's a lot of evapotranspiration, fairly light soils, so much of the water isn't taken up by the plants at all. It's quite wasteful. But there has been a really big example of where BT cotton actually failed for all the wrong reasons, and that was in Burkina Faso. So dare I say it, but Monsanto was in charge of this. And in their rush to get the product out to market, they used traditional Burkina Faso cotton lines, but they only did 3 back crosses and then said, let's get it out to market. And the lines that they released with the BT in them had a shorter fibre shorter fibre length, in other words, the staple, than the traditional cultivar. So the farmers loved it, highly productive, they didn't need to use sprays, etc. But the international markets downgraded it because it wasn't the quality that people were expecting from Burkina Faso, who had a premium market. And they lost their premium market and they lost their reputation. And that was because, I'd put it this way, of the greed of a company to try and make money when they didn't actually have a product that was going to be competitive in the long term. So let's agree that GMO is not certified organic because it doesn't fit in with the certification schemes. Now, in Australia, we have a Greens Party, and it's their official policy that we shouldn't grow any GMOs because they have not been proven safe to human health. I'm going to say that you could substitute GMOs for Alfa Romeos, kiwi fruit, peanuts, water, horses. Horses kill more people in Australia any year than any other animal. Worldwide, the phenomenon is that more people die in the bathroom than anywhere else. Bathrooms are dangerous. I suggest don't use them. Bees, we know that many people are not particularly good friends with bees, and bees have killed people. Water, it can drown you, or on a hot day, if you drink too much water, you get too low a sodium level and then you cark it. And then some people are allergic to soybeans. So we could put all these things in there, but the thing is that we've been actually consuming GMO products for 29 years and there hasn't been a single death, and no one's ever found a single zombie who was produced by these crops. I'm going to segue into gene editing because that's pretty much the sort of research that I'm working on now. For those of you who don't know what gene editing is, I'm going to explain it in very simple terms. You just have to imagine that I'm Julie Andrews. Do you want me to sing? It's okay? Oh, okay. Well, I was hopeful that you would say yes, but anyway, we'll start at the very beginning, a very good place to start. And if you read, you begin with ATG if you're an RNA polymerase II molecule. All right, well, let's see if I can make this easier for you. Do a beer, a gender neutral beer. Okay, so now, I wanted to talk about beer because I do like it, but everything you eat or drink has an effect on your gene expression. And I'm going to use beer as an example. So you drink beer and what happens next? Unless you're drinking 0.0 stuff, and even if you are, it's going to change your gene expression, but the ethanol is what I'm focused on here. Ethanol is a flavour enhancer. It's too much of a flavour enhancer for some people. It's also a toxin and it's a carcinogen. So this is dangerous stuff. So at this moment, if you get to 0.3, beer's going to kill you until your liver comes to the rescue, provided your liver is working. And there's a group of enzymes called alcohol dehydrogenase. And it's an enzyme that breaks down ethanol, as we know, takes away that toxicity, turns it into other things that give you a headache in the morning, but better than being dead. Although some mornings you don't feel like that, I know, but that gene is in every cell in your body, but it's only expressed or switched on in your liver. That's the only tissue that expresses that gene. And when alcohol is present, the gene is upregulated. So it responds to the blood alcohol content and makes more of the enzyme. Now, I will say, and this does come from personal experience, that you can train the enzyme to be at a heightened level just by regular exercise of that enzyme. Which also explains why you go on those field trips and then the person who never drinks beer discovers there's free beer and they have 2 beers and then they're the different person. But let's not go back to my student days. So there's lots of, all those ADH1 genes, they're actually there's a cluster of them and they're different loci, well, different genes, and there's different alleles. So for example, there's variants of ADH1C which protect against alcoholism. So some people don't like the flavour of alcohol. That's because they've got that allele. For other people, they love the flavour of alcohol. And that actually, if they've got that allele, it increases the risk of alcoholism. And then there's variants of ADH1B. And a defective enzyme version of those means you can't actually break alcohol down. And we all have a friend who will drink a beer or a schnapps or whatever, and their face starts to go red. That's a person who has one of those defective versions of the gene. And there's nothing else wrong with that. Well, there might be, but I mean, when it comes to alcohol, there's nothing actually wrong with that person except they have a defective version of that gene. So the differences of these other alleles, and they express more, they express less, they don't express at all, they express a different enzyme, which is quite a different one, or they express in response to different signals. So this is what alleles do. And I wanted to show you this because this is just not a human liver, but it's liver. And most people look at it and it's probably changed your gene expression anyway. But gene editing is just a way to change gene expression. You can make different alleles which express more, express less, don't express a different enzyme, or express in response to different signals. Now we can harness the ability of those different alleles, and we can go from a plant that's rust susceptible to rust resistant. We can go from horned cattle to polled cattle. And for those of you who aren't just looking at the horns, you'll also notice it's changed gender. That's because I couldn't find the right photos. But anyway, that's nothing to do with the gene editing. Honest. You have to trust me on that one. But as John Donne once said, no gene is an island entire of itself. Every gene is a piece of a cell, a part of an organism. Except he said that in 1623, and genes weren't invented until 1906, so he didn't actually say that, so I'm changing the words. But when we do GM stuff and we insert a gene in a random place, we get some random results. And here's one of our examples from sorghum. We were doing developmental genes that change the way in which auxins are moved around the plant. And these are just 4 different independent lines. And one of them, because of the position that it went into, we actually found one that reduced expression in the meristem, whereas and increased it. So you can actually get different results with different insertion events with GM. And we like using gene editing because CRISPR-Cas9, you're actually targeting the gene itself, and it's a much more elegant way of changing gene expression. If you don't know anything about CRISPR-Cas9 gene editing technology, I'll just tell you that these are the 3 main parts that you need to know about. It's very simple. What happens is, here's a target site on a piece of DNA. It recruits your guide RNA, and the guide RNA is targeted to a particular region of the genome based on its sequence. That recruits the enzyme, in this case the Cas9 enzyme, and then that enzyme makes what we call a double-stranded break in the DNA. And the big question is, what happens next? So there's a number of possible outcomes, but you're relying on DNA repair. And I told you I used to surf, and I used to play cricket, and I used to ride my bike, be a big cyclist, and this is the result of that. I've got UV radiation damage all over my skin. And my DNA repair enzymes aren't what they used to be, and that's what happens as you get older. Now, perhaps living here in Winnipeg, that's not such a big deal, but when you live in the subtropics, it is. If you look really closely, you'll see that one part of me is actually mutated to such an extent that part of me is actually albino. I can no longer produce any colours. But anyway, so what happens with DNA repair? The most common one is you get accurate repair, and nothing happened. Now, when we're doing gene editing in a plant, you get accurate repair 99.9% of the time, But because the target site is now there again, the Cas9 enzyme will do it again, and it'll keep cutting it until the sequence has changed and it doesn't recognize the sequence. So that's why it's such a powerful tool for making a change. So very often you get inaccurate repair. You'll get a wrong nucleotide will be put into the space, or you'll be missing some. You get a deletion, or you'll have extra ones. You get an insertion. You can also use a template to say, I want this specific repair to be made and change the sequence specifically. And these are new alleles. So the important thing, according to the Australian government from 2019, is that these ones, where I've made inaccurate repair, they're not going to be a GMO. If I've used a template, even if the template's only 2 or 3 base pairs, I've specifically inserted a transgene, even though it's a very little piece of DNA. So according to the Australian government, I can do this inaccurate repair type, which we call SDN1, and they're not going to be a GMO. And the reason why they decided it's not going to be a GMO is because these edits are indistinguishable from natural mutation. So there's nothing that anyone can do to be able to demonstrate that these mutants didn't come about naturally. So I think they should be organic, right? Because organic's all about natural. There's lots of CRISPR products in the pipeline. There's Phytophthora-resistant potatoes. They've actually done field trials of those in the UK and in Kenya. There's Fusarium race 4 resistant bananas. There's a lot of different wheats that are resistant to things like powdery mildew, for example. We've got a number of things that have improved food quality, such as non-browning apples, potatoes, mushrooms. Kaisha Gao from the Chinese Academy of Science has shown that you don't have to breed for fragrant rice. You can edit one gene, and any rice line you have, you can make it a fragrant jasmine or basmati type rice. You can domesticate plants just by editing a few genes. I'll talk about this in a lot more detail day after tomorrow, but we've been able to show in our work on sorghum that we've been able to, with single gene edits, get larger grain, we've been able to get more grain, we've been able to get higher protein, and we've been able to get higher digestibility of these grains. And there's all sorts of interesting things going on in horticulture. Look, I'm not entirely convinced these are going to contribute very much to food security, but seedless blackberries will be on the market very soon. You'll get brassica leaf vegetables that taste like lettuce, because why eat lettuce when you can eat something else that tastes like lettuce? I don't know. I also want to say that there's lots and lots of examples coming out where CRISPR has worked in animals as well. Scientists in Europe have targeted porcine reproductive and respiratory syndrome, which costs about 1.5 billion euros in Europe every year in pig herds. And they found an allele in wild pigs that are resistant to that. They edited that allele into domesticated pigs and have shown that those pigs are resistant. An avian flu virus, which affects all poultry, and is also transmitted to humans. So a single edit leads to resistance and non-transmission, which is as in non-transmission to humans or other poultry. So CRISPR is a really, really powerful tool. And I'll finish by saying it's actually quite simple tech that a graduate student can do regularly, many times, on many genes. And it's my belief that gene-edited crops can deliver better outcomes for the world's most resource-poor communities, because all you have to do is provide new seed with the edited traits in it. And in many cases, the farmers do not have to change what they do, but they've got a more productive and more sustainable crop to grow. And with that, I'll say thank you.
Thank you, Ian. I'm sure you'll entertain a few questions. So is this for questions to be recorded? Why do we have this microphone? Does anybody know?
It's just for the room.
For the room? Did it work? I didn't hear it.
I'm not sure.
If there's questions, I can repeat them.
That'd be great, yeah. So if there are any questions, please raise your hand.
So it seems like a lot of issues with getting the GM stuff forward is some kind of governmental issues or legislation, something like that. Is there anything that you know of, like specifically in Australia or around the world, that is some kind of group that's trying to get this stuff to make governments understand the science behind it? And on top of that, do you think, like, how likely is it that a government will start listening to the proper science?
Okay, it's a great question. So the question was about groups who are talking to governments about understanding the science of the technology, and that, I'd have to say that realistically has been going on for a long time, and it's been going on with scientists like us, but it's also come very strongly from seed companies, because seed companies have products that they'd like to get into the market. Now in Australia, like Canada, we grow way more food than we actually eat. So about 60 to 70% of our agricultural product is exported, and there's fears about export markets. That's one of the things. So it's nothing to do with science. It's more about what are the attitudes of the people who are going to buy this stuff. And so probably the biggest debate at the moment going on about GM in Australia is the Argentinian drought-resistant wheats. They've been demonstrated in field trials in Victoria, in southern Australia, that they're pretty good. They will actually increase productivity under drought conditions. The reluctance isn't from the company. The reluctance is from the marketers who buy the wheat, because they know that there's certain markets that they'll be able to sell it to, and there's certain markets where they won't be able to sell it to. And from a risk point of view, if you got any of that wheat in a shipment that was going to Germany, for example, you've got a political problem that's sort of beyond the scope of just saving $20 million because there was a drought. If I can, not trying to be flippant, but that's the sort of problem we're up against. And realistically, the barriers to it are human perceptions for a start, and attitudes, and some of those attitudes have been quite hardened in some jurisdictions. Like if you go to Germany, 80% of the people in Germany will tell you that GM crops are bad and no one around the world should be growing them. But they're all eating pork that's fed on GM soybean and GM maize imported from the US, Brazil, Argentina. But that's okay, because the pig got the worst of it.
Maybe my question is a little bit long. Is during my personal research on the dietary health, I noticed that there might actually be an impossible triangle in the food industry. Just like the three aspects of this triangle are the price, health, and the freshness, I think. And for example, if you want the freshness and the low cost, it's difficult to ensure the health because the producers may rely on the certain chemical or the preservatives. And similarly, if we want the health and fresh fruits like this, it is hard to keep the price very low because the cold chain, is very expensive. So, however, in many regions, people's income levels are very limited, it's very low, meaning it's difficult for them to afford more expensive fruits and vegetables to maintain the health. So therefore it leads to two questions. The first is, even if the organic may be partially a marketing strategy, does it still hold real value for the wealthy, I think? And the second question is for people with low income who cannot afford so-called healthy and fresh products, how should they solve these problems? So just like the presentation, should we rely on the genetically modified food to create cheaper and healthier options, or do you think there are better solutions?
It's a fantastic set of questions, quite multifaceted. I'll start by repeating the second one about basically about food affordability and are there techniques we can use to make food more affordable and potentially more nutritious? And the answer is yes, and some of those foods already exist. And so, for example, I could cite the tomatoes with high levels of vitamin D. They can be marketed at exactly the same price as any tomato, or sorry, tomato, in case you were uncertain what I was talking about. And some of them are actually combined with other genes that are involved in pigments, which make them purple. And so you can go into a store and you can select the purple tomatoes, and those purple tomatoes have a higher level of vitamin D. Now, in Australia, and the same things happen in the UK, so Kathy Martin, who did a lot of that work from the UK, she's releasing those by stealth in Australia. And in Australia, they're being released only to home gardeners. So home gardeners can buy the purple tomato, which is high in vitamin D, and grow it themselves. But she's not doing it because she believes that it should only be grown by home gardeners. She's doing it to change people's perception such that the purple tomatoes become seen as a valuable commodity and that they start to be commercially grown. So that's one such example. The first example about organic being largely for wealthy people, I mean, it's definite that organic produce gets a higher price at the market. Now, largely that is driven by productivity. If you have lower productivity, you need to have a higher price to maintain your profitability. And the research that I've read, there's no advantage nutritionally from organic produce per se, with the very, very clear exception of herbs. And growing herbs organically means when you're getting less productive herbs, in general, the flavor components and the nutritional components that are in those herbs are actually more highly concentrated. So you're getting more bang for your buck in a herb, which is great if you like the flavor of cilantro. If you don't like the flavor of cilantro, definitely don't buy organic because you're going to like it even less.
Thanks. Thanks, Ian. So I always wondered, like, so when we talk about organic certified, it's low input methods of growing food. And to my mind, GMs would fit perfectly in there. Like, you need low inputs to grow the stuff. Why and how did we reach this point where organic community started seeing GM as a no-no, like they wouldn't consider it?
Yeah, and no, okay, so the question is about potentially GM or gene-edited crops being a great bonus for organic crop production, and actually my belief is exactly that. It would be like having insect-resistant fruits and vegetables, for example, would be fantastic from an organic production point of view. Look, this is probably my data-free opinion, but I believe that many of the pioneers of organic were going into organic from a set of beliefs that said that agriculture was becoming too industrial. Big companies were controlling the food chain and the seed production chain, and hence, because big companies like Monsanto being the number one public enemy at the beginning were the people who were making these products available, it was an easy sell to the constituency to say, we're going to reject this industrialization of agriculture because that's what it was seen as. Now, interestingly, the organic industries in Europe are starting to say, maybe that was a mistake and we really need to look at this gene editing technology because maybe we should get on board with the gene editing. And one of the things that's being sold to them, so there's a guy called Urs Niggli. There's a Federal Institute of Organic Agriculture in Switzerland. And Urs Niggli, who's actually a plant breeder, he's an organic plant breeder in Germany. He recently retired, but he basically went on the record of saying, we need to get on this gene editing because it's actually going to help us with organic production. And he sold it by saying the gap between conventional and organic, we can close a lot of that gap productivity-wise to push organic productivity to get so close to conventional, if not the same as conventional, that the price differential need not be there. And that actually, a lot of the bigger organic growers in Europe have really started to listen to that argument.
Do you have any comments on the role of producers and herbicides and pesticides in the public acceptance of genetically modified crops?
Yeah. So the question is comments on the producers of pesticides and herbicides and how that's affected genetically modified crops. Well, the clearest one at the beginning that played a large role in perception of the market was really that Monsanto produced Roundup Ready crops, and it just happened to be, and we happen to be the only people who can produce Roundup. How cool is that? So they had a nice little closed market system. And this also meant that for people who are against that whole thing of multinationals, they're saying the only reason why they made Roundup Ready crops was so that they could make more money out of their Roundup. Now, of course, Roundup went off patent, became a lot cheaper. It's now being, in many parts of the world, used more than ever because it's cheap and easy to use, and you can combine it with Roundup Ready products. I think because of that, the scientific community lost the argument for BT as being BT is going to mean that you can use much less insecticide if even growing many of your crops in an insecticide-free way. The conflation with Monsanto saying we have to use Roundup it was put forward as a way as you have to buy our Roundup if you buy our seed. Straight away that made it a very difficult argument for other technologies to appear to be agriculturally sustainable. That's one thing. Now, of course, the numbers say different because the numbers actually say that the people who bought Roundup Ready crops, the reason why they liked it was they only had to actually do maybe 1 or 2 applications in your soybean crop per season, compared to the 5 or 6 different things you were using in cocktails of much more dangerous herbicides previously. But, Monsanto do have a lot to answer for that, which is why when Bayer and Monsanto merged, it was easy to see which name disappeared.
I saw a presentation recently that listed the number of new gene-edited products that were being developed, animals and plant. And China ranked far and away the highest. They're kicking everyone's butt. And I think the US came sort of a distant second. I don't know where Australia ranked. Canada didn't even surface on the list.
We'd be lower than Canada, probably.
Okay. So my question is, does it matter who is developing the new products? Especially considering that we're kind of living in a bit more protectionist world than we used to.
That is a great question. So the question was about, does it matter who's developing the product? And I think yes, it definitely does. And if a government / NGO not-for-profit, for example, releases a product, and example being like the purple tomato, people are much more likely to get on board with something like that because they can see a benefit to themselves. It's selling a benefit to themselves, and they're not putting the money in the hands of a large company. But you know, in saying that, the seed industry being what it is, no one's going to deliver the advanced genetics except those big seed companies, because they're the people who've got the distribution networks. So there will be some local examples, and very probably some of those local examples will be, for example, in sub-Saharan Africa. So the acceptance of the BT cowpea in Nigeria was because it was all done by, firstly, government organisations who then helped entrepreneurs to set up a seed distribution system in Nigeria. And that was actually technically a longer and harder road to go down than actually producing the BT cowpea itself. It was actually setting up those seed networks that allowed, firstly allowed people to have confidence that what they were buying was the real deal. Because you may not know this, but one of the things that happened in India when BT cotton first came in, within the first couple of years there was 20 or 30 companies selling BT cotton. Some of them had just nicked the BT cotton from someone else and put a new name on it. Some of them, it wasn't even BT, but they'd come into town, they'd sell BT cotton, you don't need to use insecticides in this. And guess what? When the insects started eating it, the company wasn't there anymore. They'd moved on to another town to try again next year. So those are the sorts of things that we're really thinking about with some of our sorghum and cowpea that we're working on when we want to deliver it in sub-Saharan Africa, because we've got a couple of Gates Foundation projects, and we really have to think about that seed distribution and how we do it in a way that farmers who are spending more money on seed than they would ever spend for a particular product know that they're getting what they're paying for.
Just to tweak the question a little bit, and I'm not trying to say that any one government is better than the other, or one country should benefit more than the other, but for like the maximum benefit of that innovation being spread around and utilized by farmers and the food system, does it matter where it gets developed?
Yeah, and I can see sort of where you're going there as well, in that it's true that a for-profit organisation like a seed company is going to sell it into the markets where it makes the most profit. They're not necessarily going to sell their BT maize into Ethiopia, given that it may not be the most profitable market. And that's where, I guess, private-public partnerships might be the only way to go. I can give you another example. This comes from Queensland University of Technology, which is another university in Brisbane. They developed some more highly nutritional bananas. And I don't know if anyone here is from Uganda, but Ugandans are the biggest eaters of bananas in the entire world. It's actually pretty much their number one staple food and source of starch. So the way they got their more highly nutritional bananas accepted in Uganda was they did some field days, they cooked some of the bananas in products so that people could eat them, and then they gave everyone 2 banana suckers for free, but they gave them 2 banana suckers for free and made them sign a contract to say that next year they would give 4 banana suckers to other farmers who hadn't got them. And it was, I hate to use the word, but it was an organic way of spreading a GM crop. And in some localized areas it worked quite well.
Hi Ian. Yeah, thanks for that talk. So I'm just through this conversation, I'm trying to wrestle with like what's the fundamental maybe alienation between the organic world and the genetic modification world. And I was trying to think about, so organic, I think maybe the core principle driving organic production, philosophy at least, is this idea of using diversity and creating a natural ecosystem which then manages itself. Whereas I think maybe genetic modification, certainly so far, tends to reinforce monocropping and a lack of diversity. And I'm just wondering if you think there's a space where genetic modification might actually be able to meet that core demand of organic by creating more diverse agroecosystems that would maybe at a core level address some of those issues which organic might be striving towards?
No, it's a great question, and it's about crop biodiversity and the growth of monocultures. So I didn't really talk about this, but the Gates project we're working on, where we're working with sorghum and cowpea, we're working on sorghum and cowpea specifically because in many parts of sub-Saharan Africa, Nigeria being the biggest, they're the biggest producers of cowpea and sorghum in sub-Saharan Africa, and they tend to grow them as inter-row crops. So they'll grow the two of them at the same time. So we specifically chose those because it was a way in which we might be able to deliver some benefit to a system that actually was traditional and worked quite well for them from the point of view of their own agricultural system. But I'd take it to the next level, and I'd say, and we talked a little bit about this, I've talked about this with some other people, is that we need to start from a plant breeding point of view rather than I'm a wheat breeder or I'm a chickpea breeder. We need to start to really be getting together and working out how do we breed for a farming system rather than just making wheat more productive or just making chickpea more productive. If we're using them as for example, as a rotation, how do we breed both of them to get the most sustainable cropping system, but also to get productivity? Because it may be that the wheat line that gives you 100% top productivity, if you went to the one that gave you 90% top productivity and the chickpea that gave you 90%, but they together work really well to turn that into 110%, that's where you need to go. But of course, that's complex. It's really hard for, it's hard enough for a single person to run a breeding program. For a single person to then run a breeding program that was breeding for a farming system, and a farming system that's going to change, there's a level of complexity there that we have to get our head around that. And so at UQ in my centre, we're actually trying to use predictive agriculture and AI to predict some of those outcomes. And we're actually using predictive breeding to try and predict some of those. And then we're going to actually then breed for those outcomes. And in 5 years' time, we'll know, A, are we successful? B, we haven't moved the dial a bit? Or C, we've actually made it worse. I'll just retire, it'll be fine.
I just wanted to ask you about pesticide residues. Like, is there some evidence that pesticide residues are bad for us? And would
Yes.
the organic system keep that up?
Yeah, so the question was about pesticide residues. So yes, the pesticide residues, some of them in particular, are pretty awful things that you don't want to be eating with your seedless blackberry or whatever, especially in fresh produce. We like to think that in places like Canada and Australia that we're doing the right thing, and there's government systems that ensure that those pesticide residues are kept at a really, really low or non-existent level. But you also know that they can't test everything. We also know, so I know for a fact in some of my colleagues work in the Mekong Delta in Vietnam, and there's a lot of citrus and vegetable production goes on in the Mekong Delta. And the amount of sprays of pesticides and herbicides that have been banned everywhere else in the world that are going on in that place means that there's no fish in the Mekong Delta anymore, except for the prawn farms. So what I'm saying is, don't buy prawns that are made in Vietnam. No, but no, it's definitely a real issue. And yes, organic production is going to be free of those residues, but you can also demonstrate that in certain types of conditions, particularly under wet conditions, there's going to be some fungal contaminants that are potentially just as bad as a herbicide, sorry, as a fungicide for you. So it's things like ergot and those types of things in grains. So there's no answer that's a good answer, but definitely in organic systems, the levels of pesticide residue are considerably lower, if non-existent. And you're probably not going to get enough copper off your grapes for it to be a problem.
Any more questions? Yes, go ahead.
So I have a question about what's the purpose they develop the non-browning apples and mushrooms and fruits from food? Because people usually they look for how the person put out meat to decide the foods are ready to eat or is that still good to eat. And for convenience, we usually involve the fruits or fruit in markets. But if they don't brown it anymore, so how do we decide it? It makes some confusion to it's good to them.
So the question was about non-browning fruits and vegetables. Now the browning comes from oxidazes which oxidize the polyphenol. So you cut an apple and then the phone rings and you go and talk to someone on the phone and you come back and the cut edge of the apple has gone brown. So if you knock out the polyphenol oxidazes, the apple doesn't go brown. Now, that's not a big deal necessarily for you eating one at home, but if you're slicing these things up and processing them, turning them into dried apples, juices, etc., the browning is a big problem that you have to be concerned about. And it's the same with potatoes. If you're making various potato products, you don't want those potatoes to start going brown as soon as you've sliced them up for chips or fries or whatever the outcome is. I mean, the Arctic apple, I don't know if you've seen the Arctic apple, which was, they knocked out the PPO in apples in the US, and that's a really funny one. I mean, they're helping people's food security by slicing it up and putting it in a plastic bag, and you buy the plastic bag already sliced, and it seems like that's probably a really good way to make big profit on something that's potentially not worth that much. But maybe you could also do it with a squeeze of lemon juice. Yeah, mushrooms was the same thing. So when you're processing mushrooms, if you can get rid of the browning, you can actually can or whatever mushrooms that look white rather than dark brown. It was to do with nothing to do with taste. It's to do with human perception of the product when they see it.
Sure. Okay.
Yeah. So, from a historical perspective, a lot of these lump them under kind of green revolution technologies have kind of failed to provide benefits for the most food insecure farmers, especially in areas of sub-Saharan Africa. Are these kind of genetic engineering or genetic modified technologies any better poised to kind of benefit these farmers who might be able to access them the least?
Yeah, that's a fantastic question. So the question is about how the green revolution hasn't delivered things to many farmers, particularly in sub-Saharan Africa. I think one of the main lessons that we got from the green revolution was, yep, you can make wheat dwarf, semi-dwarf, you can increase harvest index, it won't fall over as much, you can harvest it with a mechanical harvester, much more easy, and you're making the assumption that the straw has no value. If you're living in Ethiopia and you're growing sorghum, you want to grow sorghum that's 3 meters tall. And the reason why you want to grow it that's 3 meters tall is you take the grain, and that's for you to make beer, injera, porridge, etc. But the rest of the plant, you need that because that's what you feed to your goat or your cow, or you dry it and you use it as firewood, or you use it to make fences. So in many parts of the world, we forgot the fact that in the in many parts of the world, it's not just about the grain. The whole plant is actually valuable, and probably I'd say for sorghum in many parts of sub-Saharan Africa, the stover, the non-grain part, actually has a higher value to the general community than the grain. So it's not merely food security. It's a building product. It's what puts the roof on your hut. It's what makes the fence to keep the goats in. It's what you feed the goats and the cows. And therefore, I mean, in Australia, we grow sorghum that's this high. It's never going to work in Ethiopia or Kenya because all we're doing is giving them a third of part of the plant that they're no longer going to be able to make a fence or get very much firewood out of that.
All right, maybe we'll end the questions here. He's answered questions for quite a bit now, and he's promised to give us another seminar on Thursday morning. If you got any pressing technical questions, maybe take them there. So please help me thank Ian one more time for a thoughtful.
Thank you, and thanks for being such a great audience.